I know there were some questions about how to do the residual problems, so I wanted to walk you through some parts of number 28 on your quiz review so you're ready for it tomorrow. So all of the x values get transferred into the first column, all of the y values into the second. Okay, those are the actual values for the x's and for the y's. The model is the equation they give you. That's the one you're testing to see if it's a good fit. So what you'll see in this first one is I plugged in the x value 4, and that gave me a negative 4. The last column is define the residual. And define the residual, you're going to do the actual minus the predicted. Okay, so what that means is I took the actual y value, which was negative 1, minus the predicted, which was negative 4, to say that it was 3 more than we expected. So the point we're going to graph is x, comma, the residual. So we'll go 4, 3, and we'll put a point. On this graph, what we're hoping for is to have the same amount of points below and above the x-axis, at least congregated around them. I'm hoping to stay between 2 and negative 2, but that's not always the case. It definitely can't make a U-shape for it to be a line of good fit, and they can't all be above or all be below. So let's do another one. So for the next one, we're plugging in that 6 because that's the x value. So that was nice of them to give us some even numbers. So negative 3 minus 2 is a negative 5. It was negative 3. We thought it was going to be negative 5. So it was 2 higher than we expected. So we'll go to 6, 2. Okay, so I graph 6, 2. Let's do the other one. Negative 0.5 times 8 minus 2 is going to give you a negative 6. We thought it was going to be negative 6. It was negative 6, so it has a residual of 0. So I'm going to go to 8, 0. When the point is on the x-axis, that means that the line that they drew, this negative 0.5x minus 2, actually goes through that particular point. Okay, it goes through the point 8, negative 6. So it's on the line. Let's try the next one. Negative 0.5 times 10 minus 2 gives you a negative 7. We thought it was going to be negative 7. It was actually negative 8. So negative 8 minus negative 7 equals negative 1. We were 1 less than what we thought. So we go to 10, negative 1. Okay, try another one. Negative 0.5 times 12, and you can use the calculator to help you. That's a negative 6 minus 2 is a negative 8. We thought it was going to be negative 8. It was actually negative 10. So actual minus predicted means negative 2. It was 2 less than what we thought. So here I am at 12, negative 2. Negative 0.5 times 14. And at this point, you may feel like you don't really need to watch anymore. That's fine. Okay, but I'm going to go through the whole thing. It was actually negative 10. We thought it was going to be negative 9, so it was 1 less. So we're at 14, negative 1. What you're starting to notice is it's making that U shape. That's going to let us know that it's not a good line of fit. So I'm going to go to the next one. Negative 0.5 times 16 minus 2 gives you a negative 10. We thought it was going to be negative 10. It actually was negative 10, so that one's on the line at 16, 0. Negative 0.5 times 18 minus 2 is a negative 11. It was negative 9 minus that negative 11 equals 2. So here we are at 18, 2. We've got one more. So negative 0.5 times 20 minus 2 gives me a negative 12. We thought it was going to be negative 12. It was actually negative 9. So that gives me 3. So here I am at 23. 23. Notice how those residual points, they make that U shape. That means this is not a good line. Now, if you wanted to know what was a good line, you could put these in for your list 1 and list 2. You could put them into your graphing calculator, into the STAT program, and that would allow you to see what the actual line of good fit is. It doesn't ask you to do this in this problem, so this is sufficient. The first one here on 27, you can say yes, it's a good line. Okay, that's because the points are pretty congregated around the x-axis, but really evenly balanced top and bottom. Even though we go all the way up to 4 and 3, they're still pretty close to that x-axis. So this is enough to say, yes, that's a line of good fit. But anytime it makes this U shape or there's majority above or majority below, that will be a no. So that's what the residuals show us. Okay, they show us whether it's a good line of fit or not.